$62. There you go. Where are we at? Oh, okay. All right. There's one school of thought, I always forget to say this, that says the mean, the null is always equal, no matter what, which I find to be utter bullshit. Because if my claim was that the mean is at most something, right? Where would that go? In the null. So how can the null always be equal? But there, every now and again they have that idea creep in, where no matter what, the null is equal to. That's one school of thought, right? And it's like, a lesser school, but it's too bad for them. So there are a couple, most of the time they kind of agree with the right way to do things, but sometimes I have that sneak in. I think that one is like the only option that's really close to what should be true. What was it, 60? What did you say, 60?
62
E.
But they have you make it up yourself.
Yeah, fewer than 5% of adults. So that would be, p less than 0.05. So the null should be p greater than or equal to 0.05. Oh, okay. There was this one where it was like multiple choice, but so yeah, they're wrong. It's okay. There's typos. We'll pretend like it's a typo instead of an incorrect way of looking at life. I like it. Some of you guys don't realize when there's a discrepancy because you only write down what's in the solutions. Well, you live a life of bliss. Yes? Oh, the one we just took?
No, this one. You want to just go back?
Oh, yeah, sure, of course.
What were we supposed to write for the conclusion for the confidence interval?
I'm not sure to answer that.
Because you circled mean.
Totally. Is that for number 2?
Yeah.
Yeah, what was number 2 about? Percentages. So no way it should be talking about a mean when there's a confidence interval for percentages.
So you put mean percentage.
But see, that doesn't make any sense. You know what I mean? It's either a mean
So you just put percentage.
or it's a percentage. It can't be a mean percentage. Yeah,
Or you put a true percentage.
I like that. So you got the mean percent. You got the nice percent. Anything else? You guys have any questions from that quiz I just gave back? Okay. Man, imagine if I was really an asshole teacher, man. Oh my God, you guys, I don't know what you guys would look like, to be honest. If you think I am, you have no idea. Okay. This is Jeff letting off some frustration. There's one section in chapter 10 that we do. If there's no questions left over from 9, we're just going to tackle that one. The really nice thing with chapter 10:1, section 10:1 is all the steps are the same. And I'm even going to be insane and say that the z-score formula is the same too.
We are?
You guys all right? Huh? All right. So the idea with 10 is even more closely related to real life. If I develop a brand new drug, do I have any information about how it affects anybody yet? No. What's the only way I can find information about how it affects people is to take samples of people and give them the new drug and give one some placebo and give some nothing, right? And then all I'm going to get is sample data. I'm not going to know anything. Now, if I'm trying to, so the point this section is making is I don't have a known mean to compare to. There's no, so for example, let's forget about the third group. Let's say we don't have a control group. We're just going to give one group the meds, the new medication, and the other group a placebo, sugar pill, right? So group 1 gets the new medication, want a new drug, and the group 2 gets placebo. So from group 1, let's say that we have an N1, we find an X bar 1, and we get an S1. It's all sample data. And so there's no known population information at all to compare this to. What am I doing then? What am I comparing? What will I end up comparing? What am I comparing? Yeah, one group to the other group. One sample to the other sample. So all the hypothesis tests in chapter 9, we're comparing one sample information to some known data, right? Some known data point. Like we know that the percentage is 20%, and or historically it's been this, or we feel it's not 10% anymore, or something like that. It's always something that's given to us. Here I've got two samples, not just one sample. So what's going to happen with my z-score formula is everything's going to have to double up. I'm going to have a place to put x bar 1 and x bar 2. So the one sample z star look like this. So the two sample z star is going to be bigger because it needs to have room for both samples. Now somebody help me out. Remind me, I had it up here earlier. What was sigma x bar? Yeah, sigma over square root of n. So just let's make this closer to what we're talking about here. Go ahead and make this an S. But it's all the same idea. Still a standard deviation. Let's make it closer to our two samples. Now the top is easy enough. So let me try to write. Here's going to be the new. Let's write the new one for this kind of situation. New z star. See what that's going to look like. So now instead of just one x bar minus the mean, I'm going to have two of them. I'm going to have x bar 1 minus mean 1 minus x bar 2 minus mu 2. I'm doubling everything. Why am I doubling everything? Because now I have two samples. I have two populations. So this group would represent the population of people that get the medication, and this one would represent the group of people that get the placebo. But there's a sample of that group, right? How do we know so far? All I've done, what have I done? I doubled it. Why? Because I have two samples now, not just one. All over. Now here's where things get weird on the bottom. So I got to go back and focus on this. I know every time I say here's where things get weird, I know somebody out there is like, you passed that point. I'm going to do a little bit of weird algebra stuff to this. Slightly weird. I can't really put these together, but let me do this. If I make it one big ass square root, what would have to go here? S squared. So now I can double up that also. I can double that up. Here's what that looks like if I double up on this. It's going to be square root s1 squared over n1 plus s2 squared over n2. So that, I'm arguing that formula is the same as that one. It's still, it really is, which is really freaky. Now, let me kind of rewrite the top a little bit to make it closer to what we really want. I just kind of doubled up that expression, but let me put it closer to what's going on. Okay. So that's a little bit more direct. This is the difference between our samples, right? So maybe this is the average length of time the sample took to get better. I got this new medication that's supposed to vastly improve on the amount of time it takes to get better. I love the looks. Everybody's cool with what I just said, right? I'm trying to. No, what's the matter? So let's say that what I'm looking at for my new drug is the average amount of time it takes for this group to heal. So this new drug I've just created, it's supposed to help wounds heal faster. Does that make sense now? Is that all right? So this expression would be the difference in the average times between the two groups. That's exactly what I want to analyze. Now, what if my new drug doesn't do anything? What would that mean about the difference of the population averages? If my new drug doesn't do anything better, it's the same. That would mean that mu1 equals mu2. That would mean that the population of people that take my new drug and the population that don't take the new drug, they would be equal to each other. And in fact, normally that's what my null hypothesis is that mu1 equals mu2. And in fact, that's what we're going to assume it always is. So if mu1 equals mu2, what happens to this expression? If mu1 equals mu2, this is 0, right? The two things that are equal, the difference is 0. Okay. So now all the steps are the same. And it sort of feels like when we talked about p hat and the percentage stuff, I had a new z-score formula, right? Now here, this is what I'm going to do on step 4, but all the steps are essentially the same. Okay, so let's try this out. This is our new little... Now we do have a little something. I know I put z star here. I'm waiting for somebody to... This should be t star, but again, I don't care. It's just the measure of how far apart these samples are. Right? Which means I've got to have a way to figure out what? When I have t-scores, what do I eventually have to use to get a t-score? What do I use to get a t-score? You can take away my freedom. Right? You can't take it to the degrees of freedom. So, what's kind of weird in this situation for figuring out degrees of freedom? What's a little weird? How do you normally figure out degrees of freedom? N minus 1. Well, there's 2 frickin' n's, right? So we could use this disgusting formula this book seems to enjoy. Or we could do the standard practice of saying degrees of freedom is the smaller of n1 minus 1 or n2 minus 1. You just take the smaller one. Whichever one is smaller. So if this had 40 people in it, and this had 30 people in it, then my degrees of freedom would be 29. I just take the one that's smaller. Instead of the remarkably heinous formulas in there. All right. So all the steps are the same. All 5 steps are the same. It's just how do I accomplish finding out how far apart things are? It has to be different than it was before because I have 2 samples now. So that's how I figure out how far apart things are for that 4th step. Are they far enough apart? This is how I figure it out. Let's try a problem. Let's try. We haven't done a problem yet. We just talked about how it's going to work. Let's try a problem out. Let's take this away. Yeah, all right, let me just use what I've got up here. Let's say that we do have this happening. And I give these 2 groups this new medication. And let's say the first group has, what do you got, Jeff? 82 people in it. And they get an average time until they're healed of 3.14 days. And my standard deviation is 1.56 days. And the placebo, let's say that there's 74 people there. There's absolutely nothing wrong with those 2 numbers being different. Does not matter worth shit. So let go of that. X bar 2, let's say, is 4.17 with a standard deviation of 1.19 days. All right, is everybody cool with what's happening? So I gave these guys this new medication. It took them this long for whatever this thing is to heal. It took these guys this long for whatever it is to heal. So now let's see if there's a statistically significant difference between those times to heal. That's what we're really going to investigate. So let me put some stuff over here since I have very little board space left. We have very little camera space left too, but oh well. So, based on what I said, can somebody tell me, based on the whole idea here, what's the claim? What's your claim always have to reference for a mean situation? It's got to, we make a claim about mu, but in this case, how many mu's do I have? 2. So what's the claim about the relationship between those two? I think my medication, careful, the time it takes for my medication to make you heal, I think it's less than the placebo would. Are you with me? Okay. So I think, so the claim is mu1 less than mu2. Less than does not always mean worse. Right? Like gulf, which is something I don't do, but still.
Is this stuff in your stuff?
Yes. I love that question. You're really saying, should I pay attention? Yes. So which one is this, HO or H1? H1, definitely. So HO is going to be officially yeah, so it includes an equal to option, right? Yeah. So how many tail tests will this be? One tail? One tail. All right, I mean, all right, so far is it really, really different? No, there's one little difference here. We don't have any numbers here because we don't know any numbers. Of course, we got 2 samples investigating stuff I have no idea about. So it's just going to be a claim about how those samples populations are different. Or if they are different, yeah. What's the second step, always? Z or T? Zort, all right? Zort. So, which one? Which one can I, or do I have to use? T. Why T? Both ends are greater than 30. Okay, I like it. All right, same stuff. That's the requirement when we talk about means. When we talk about percentages, it's NP, NQ greater than or equal to 5. When we talk about means, it's the sample size greater than 30. Or like on the quiz, I just say it's normal. Doesn't matter if the sample size was 12, 13, 8, whatever. Because I told you it was normal. And now how do I determine which one? Now I know I can do something. How do I tell which one it is? Yeah, the only standard deviation I know is S. I don't know sigma or sigma 2. Unknown. Shit. So I can use what? I have to use t-scores. I need the thing that was invented for this situation. Yes?
So if 1 is greater than 30 and 1 is less than 30, what?
Then I'd have to have something that's telling me why it's normal enough to do it.
Okay.
I'd have to know that it started off symmetric or looked normal to begin with. You know, there are other things you could do. But if I didn't have any of that and it's less than 30, officially I can't do it
Okay.
at the stats 1 level. Third step is what? The third step is rejection region. Rejection region. I'll make a little cartoon out of it. So here I got to tell you what alpha is. That would be nice, Jeff. So say use alpha equal to 0.05. That's the one that's most often used. What's my degrees of freedom? Degrees of freedom. 73. Right? The lesser of n2 minus 1 or n1 minus 1. And of course, we're going to have to go below that because our chart doesn't go to 73. So we're going to have to use what? 70. I like it. Alpha's 0.05, 70, and it's a one-tailed test, right? So can somebody help me? It's going to be, where's the tail going to be? Down here. So degrees of freedom 70. Alpha's 0.05, one-tailed test. It's got to be negative. So there it is. Yeah. So negative 1.667. I like it. What's up? Did I look in the wrong place?
Why is it negative?
Oh, why is it negative? Because the tail is down there. Of course. Yeah, so T-score chart, there are no negatives on the whole thing. Because the T-score chart says, you're the freaking human, you better know something, and we know that it's down here, so it's got to be negative. Yes?
Why did it go, the degrees of freedom go from the 73 to 70?
Officially it didn't, but for us, our chart doesn't go that detailed. So you just got to go to the next thing down. Yeah, just to be more conservative.
I don't know how to word my question. Like, if the mean, like say we had a mean, and it was positive, but it was still like on that side, it would always be negative. Like it couldn't just be under.
I'm not sure what you're saying. What's
Like
here?
if the mean's 15,
What's here?
0.
0.
But if your mean's 15 and it's supposed to be under 15, it always still has to be negative.
Yeah, what if your mean is 15 and the claim is less than 15, then
Oh, because
it's going to be negative because it's below the mean. Yeah. What's happening? That's nothing new. I thought maybe your concern was, do you notice how I call this group 1 and group 2? If I would have switched those, this would have been switched. I thought maybe that's what it was asking about, but no. I get the feeling maybe not. You're like, I don't know what you just said. I didn't even think about it. Shit. So as long as you're consistent with who are the 1s and who are the 2s, you're good. Other than that, I'm not sure what to say, because we've known this forever. If it's below the mean, it's negative. Okay? And then step 4 is right here. Right? I'm trying to help you out, but I can't. I don't know what else to say about that.
so I get
No, we're
it.
good.
It's just
We didn't do all our tests, so now we're freaking out.
Oh, I see. Okay, now I understand. Sorry. So now I just got to plug and chug stuff into here. Yeah. I love the one time somebody had never heard that expression before and they thought I was being crude or something. No. So what goes up here? Probably x bar 1, so 3.14 minus 4.17 divided by square root. The mistake people make is they forget to square that poor little dude. Let's see if we can all get the same T star here. Bless you. Bless you. Ooh, that's freakadelic. He's got a slow leak over there. What do you guys get? Anybody got something yet? Blank screen? All right. Really? Anybody? Nobody? Anybody get something? Yes.
will the means always cancel out like
In general, no, but then the claim would have to be something like, I think my medicine can heal them in one less day. It has to be, in the claim, there's got to be a specific claim to the difference.
So you just like assume that they would be the same.
If there's no claim about the difference, then we can go ahead and assume that the null is that they're equal to. So we're not going to get into the situation where there's a specific claim about a difference. Like if I said, my SAT course can provide you with 200 more points. Now I know what the difference between those is, and there would be a 200 sitting there. Here, the claim I'm fighting against is that there's no difference. Does that make sense? Or the idea is that there's no difference between my drug and a placebo. I'm fighting against that. So that's why mu1 equals mu2 is the assumption. And I'm trying to show evidence that there is a difference between these. That difference is bigger than 0. I don't know. No, he's still in. It's negative. I got 466. Negative 466? Anybody else get something different? Same thing? 466? 466? You got really damn close. And you're the only one that spoke up, so kudos, but you're still wrong.
That's really not that useful.
Now so what's that mean? What's that mean? Yeah. Did we make it far enough away? Oh, hell yeah, we blew the shit. Look at that. We're like -4. We're like way the hell down here. So we're totally in this rejection region. So that was being in the rejection region. What does that mean, us being in the rejection region? Reject the whole, probably, because it's the rejection region. So I can reject the low, support the high.
Oh.
Okay. Now I know that some of you guys are like, oh, it's more of this shit, but some of you guys really should realize, thank God it's not that different from chapter 9. It's almost the same exact thing. Thank the gods. It could have been completely different. So what's my conclusion I can write now? What's my claim? Which one was my claim? Which one was my claim? The high. So I'm going to use that language here. We found sufficient evidence to support the claim that the new drug lets things heal quicker than a placebo. That would be it, right? So it's exactly the same as the stuff from chapter 9. It's just the Z-star formula or the T-star formula, whatever you want to call it, has gotten a little bigger to make room for the extra data that I'm getting now. I got 2 sample information that I have to put somewhere. Okay, so let me let you guys try one. Take one right out of the book. Okay, here we go. So we got what they want from here? More than you wanted? I understand. Okay, so here's this problem. Okay. Oh, yeah, that's right. There we go. Much better. All right, so here's let's see. All right. A student at, let's see, a student claims that enrollment at four-year colleges is higher than at two-year colleges, which, if you don't know, is where you're currently enrolled.
What page is that?
Page 561, number 78. So they collect data from 29 males and 16 females. Oops, sorry, where am I at? Here we go. I'm looking at the one before that's awesome. 35 two-year colleges. And here's what they find. The mean enrollment was 5,068. And standard deviation was 4,777. Kind of makes sense. And from these silly people, they looked at 35 four-year colleges and they got this information. X bar was 5466. Standard deviation of, woo, look at that, 8191. That's crazy. So test the claim. At a level of significance of 0.10. Just to make this point clear from what I said earlier, choose one group to be the ones, choose the other group to be the twos, and remain consistent, and you'll be fine.